Alrighty, 7 o'clock. I'm going to go ahead and get started. So thanks for coming to the preference learning talk. This is a pretty small group. I don't really know people like from inside Discord, but I'm going to maybe like be slightly tailored to the people who are in the room. So I just made a brief intro deck just to contextualize for like people who are interested in like the EA Philly stuff, just to contextualize what the talk looks like. It's just 9 or 10 slides. We're just gonna go over why altruists are interested in extinction level events. Talk about how human in the loop learning like relates to extinction level events and why the extrovert community is interested in this area of machine learning. And then Lewis is going to do a talk that's 31 slides, and then the Q&A and discussion is not really structured or planned or anything like that. So effective altruists, believe that many things are broken and that they could be fixed if we tried. They believe that many things are bad and they could be good if we tried. And that's basically like what effective altruists are kind of all about. One of the reasons we focus on the future has to do with indifference, right? So we're geographically indifferent morally, right? Like we don't think that like people are worth less because they live far away from us. Because that's what cosmopolitan indifference is all about. So the idea with the future is that cosmopolitan indifference also applies to time. More humans live in the future than in the present. So there's a fact for you. We do believe that the future is essentially under attack. So the effective altruist consensus is that preventing catastrophic and extinction level events is important, neglected, and intractable. A catastrophe is something roughly worse than COVID. An extinction level event is something we can't bounce back from, right? So both are of interest. We think that there's like stuff you can do in this space. So again, the effective altruist consensus is that software is a likely source of catastrophic or extinction level events. And this is like a claim that not everybody buys, but like surely there's the weaker claim that like they'll be enormously influential over the future, which is where most people live. So like AI is going to be really important if you're interested in like doing good and stuff. And just some comments about like AI work is that like if like more people are working on safety than on capabilities, like we couldn't turn this around. It's not inevitable the way it's going to go. But like because everybody's bottlenecked on talent, it really like matters like what you choose to do. So I was talking with Lewis earlier about this, how it's like preference learning like has a role to play in capabilities, of course, and rather than safety, like I believe like it's related to like the Stuart Russell kind of stuff about preferences are human preferences are the sole objective of a machine that we want to design, right? And the machine can be uncertain about those preferences, but it can get information about those preferences from humans. And Stuart Russell believes that this is a very safety critical viewpoint. So even if earlier Lewis was telling me that preference learning is actually very capabilities, there's a lot of interest in preference learning that from like a strictly safety perspective. And I'm just I can do this part really fast because of like the audience and who happened to show up. But basically, a training process acts in the world to maximize a given crafted reward function. If your system is powerful enough, a mistake in the reward function will be very bad, i.e. solving cancer by killing cancer patients, right? This is something that like you can mess up your reward function and accidentally do. So training processes that are reliable less bad in this way are good and important. That's why like research into like human in the loop training processes is very interesting from this perspective. So when a training process relies on human activity rather than a static data set, we say that this process is a human in the loop training process. Plausibly, the literature on human in the loop training processes is a good place to look for ideas on how to make software that doesn't kill everyone or most people. That's kind of I'm pretty sure that's a pretty uncontroversial thing to say, like if you're like familiar with like the ML and ML safety kind of field. And there's been like a lot of work kind of in this space. So yeah, that's all I'm going to say. I just wanted to cover some of the prereqs so that Lewis didn't have to like go over prereqs. So there is an EA Philly Discord. If a couple of you aren't in it, a couple of you aren't from Philly, yeah, for Philly, I'm just going to say tomorrow our friends the ACX meetup are doing a meetup. Friday, Steven's giving a talk in this room that also is like toes this line between capabilities and safety. On Friday evening, we have a social in Chinatown for like alignment folks. And on June 17th, we have a reading group /social on long-termism and the hinge of history hypothesis. But that's really only applies to people who are like in the room physically, not applies to you wonderful people on Discord. And so anyway, here is the introduction of our speaker for today, and then I will hand it over. Louis Cascicato is an incoming PhD student at Brown, supervised by Professor Eli Pavlik. He does undergrad at University of Waterloo in pure mathematics and master's at Georgia Tech in NLP/narrative theory under Professor Mark Rydell. He currently leads the contrastive learning group at Eleuthera AI and has a multitude of projects in the representing human preferences space. That is it for me, and I'm going to hand it over now. Thanks again, everybody.
All right, let me make sure that I can. Where are you? Shoot. Sorry, one sec. There it is. Oh, no, not share. Slideshow. Okay. Just a sanity check. Can you guys, someone's gonna have to check the voice chat.
Yeah, I'll check the voice chat right now.
Can you guys see it? On Discord? Are people saying if they can see it?
Yeah, actually, no, you're still looking at my slides on stream. No, you're looking at your slides on stream.
Okay, perfect. So, this is CARP, the Future of Preference Learning. Can you mute?
Sorry, I'm trying to. It's giving me trouble. Okay. My bad.
So, who am I? I'm Louis Cascicato. I'm a research scientist at Eleuthera AI. I'm currently a research intern at Hugging Face, as well as an incoming PhD student at Brown. I'm mostly interested in frameworks of frameworks called theoretical storytelling, stochastic frames, reasoner models. In the case of storytelling, that's often referred to as reader models, stuff like Lobb's theorem and model theory, and how this relates to NLP as a whole, how like these formal semantic models of storytelling can relate to our current trends in NLP. And for AI safety, I'm mostly interested in AI safety framed as normativity. How can we extract social norms from well-established online communities? How can we predict these norms over time? And then what can we actually do with the norms that we extract? How do we model them? How do we incorporate them back into language modeling? How do we make language models more tailored to these well-established groups? So how do we talk about norms usually? Most existing literature in normativity or normative alignment is focused on storytelling or extracting norms from stories. Inherently, fables are always about normativity. So the lesson at the end of a fable expresses some notion of normativity, or the character arc can also express normativity as a whole. As humans, we derive our understanding of social norms from stories, so we express them as stories to other humans. When you express some notion of norms or some normative common sense to another human, in turn you are telling a story about those norms. It is possible to track the evolution of norms through history by looking at normative literature over time. So looking at how like character arcs progress from like the 19th century to the 20th century to the 21st century, and given this kind of information, you can begin to look at predicting norms by using storytelling. At the end of the day, normative alignment equals value alignment. If you can extract the norms of cultures and extract the norms of subcultures, you can model them, effectively you are gaining the ability to do value alignment. Current trends in normative NLP use data sets like moral stories, Goofus and Galliant, and the moral integrity corpus. There's also some stuff with like Reddit, am I the asshole? But I'm not including that because it's not inherently normativity. It's value alignment, but it doesn't use this normative scope. If we want to extract and model normative behavior, storytelling is therefore a very natural direction to pursue. So why not use stories? Storytelling is really hard. It's perhaps one of the hardest NLU tasks that we can do. So stories at the very primitive level are a summarization of any dynamical system over time. This includes things like data visualization, and normative behavior can also be expressed as data visualization. So the definition of stories is incredibly broad, but this also gives us a huge benefit. There's a number of directions to explore stories through each of these individual avenues, and there's also general methods to explore storytelling as a whole. So when we evaluate stories, because when you evaluate normative behavior, you have to inherently evaluate stories, and most of these methods use things like pairwise comparisons between stories, because that's typically how stories are evaluated. However, stories and hence norms have an infinite number of axes and cannot be expressed as simple comparisons. There's a million different ways that one story can be more normative than another, so there's no objective way to say story A is more normative than story B. So this kind of sounds like we're just creating impossible problems. We're going from the goal of learning normative behavior to the goal of generative storytelling. But the real benefit is that when you look at it through the scope of storytelling, there is an insane amount of data that's available. So under the definition of storytelling that we gave, this includes all social media, the entire history of written literature, every news article and chat interaction, visual media, interactive fiction, as well as interactive nonfiction, and the little robot emoji over there. I don't know if people can see it. So this classification of stories is actually extremely useful to us if we want to start exploring norms. So how do we evaluate these stories? Even if we have terabytes and terabytes of stories, evaluation is non-trivial. Normativity is inherently context dependent. It depends on the biases held by the reader, it depends on the biases held by the author, and it depends on tons of external factors. Different cultures encode different normative behaviors, and when they read stories, they project their norms onto the stories and might interpret stories entirely differently. So current value alignment literature focuses primarily on preference learning, but that only really accounts for the preferences of an individual, and it only really accounts for the preferences of a very, very small individual of like college-educated white males living in California or whatever. It's not really, you're not really doing preference learning at scale if you're only limiting yourself to very small subsets like that. So we don't simply accept stories and the norms they encode. We also have to apply a very thorough analysis to them. So we have to critique the content of the story. So when a human's reading a story, they evaluate it by thinking of what might be wrong about the story. So if a story is too scary for you, you might think in your head, oh, this story is too scary. At the end of the day, this is referred to as a critique, and it is how humans express either enjoyment or disdain for stories. So if we want to evaluate stories in the way humans evaluate stories, we need to begin to model critiques. So we would need a very large data set of story critique tuples, as well as an easy way to model their association. So there are plenty of candidate data sets for this. You can use editor manuscripts of stories, you can use debates. And at the end of the day, we also want to use contrastive learning, because if you have a classification problem that's over an infinite number of axes, contrastive learning is a very natural approach. So at the end of the day, we want to learn some shared embedding between the relationships of stories and their critiques. Enter the story critique data set. So we scraped a data set of about 1 million passages and critique tuples. Each pair consists of an excerpt from a story and a critique that corresponds to that very specific excerpt. For an example is, Billy has a big hat. I think Billy should have a smaller hat. While relatively noisy, a significant source, while relatively noisy, that's so weird. Okay, the data quality is highly varied, and a lot of phrases are only present within the data set. So they're very, very specific to the stories that are being told. This tends to be an issue with like sci-fi stories or like fantasy stories. But you know, if you're going to scrape a data set of 1 million stories and critiques, you're going to be getting a lot of stories like that. And the data requires a significant amount of data processing for privacy preservation and to avoid the model just cheating on syntactical structure. So for data obfuscation, the model can easily cheat by matching various words within the passages and critiques. If there's only one story that has a character named Lewis, any critique about a character named Lewis is obviously going to match with that one. So you want to remove the possibility that you're doing matching solely on co-reference resolution, or you're doing masking based off quotes from the story. So we obfuscate the story by using quote tokens, by replacing excerpts in by replacing portions of the critique that refer directly back to the story with a special quote token, and we also anonymize all the names. So any male name gets replaced with John, any female name gets replaced with Jane, and any gender neutral name gets replaced with Sam. So sometimes reviews are also useless. Like you get short reactions like this. For that, we just prune any review that's less than 8 characters. Just to note, this is very specific to storytelling. If we were dealing with a code data set or a data set of like Reddit comments, we wouldn't have to deal, we would have a different data obfuscation process, but it wouldn't be this specifically. At the end of the day, we end up getting a model called CARP. So CARP consists of 2 text encoders trained contrastively on passage critique pairs. And we have a joint representation of critiques and stories within the latent space. And we have a confusion matrix on the right, where we have the lazy brown fox jumped over. If they're lazy, why are they jumping? In the end, he couldn't get what this is the ending of me wanting more, yada, 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 and then all the way down the side. And we can see that when it actually does get confused in the classification, what you're using as a critique that could apply to any of those. So it is semantically very robust to what's going on within the story and does provide a very useful metric for evaluation. Text encoders for CARP are also based off of declutter or Roberta. We found that declutter provides a significantly better result. And we get to that later, why we think that declutter is just a much better contrastive, much better base model for models like CARP. So the training process is very similar to CLIP. We don't use hard negatives. This is a topic of future work, and we use a very large contrastive batch size of 2048. So there were various engineering techniques that are required. Things like contrastive parallel, which is where you split up your contrastive learning batch over multiple GPUs or over multiple time steps to go from a contrastive batch size of 128 that you could fit into 1 GPU to the 2048 that we needed. And we also use learn temperature, which allows the model to control its own level of annealing. What we found that the learn temperature tends to converge relatively quickly. So for later models, we just turn that off and we use a fixed temperature of 1.26. That was just empirically determined. There was no real reason it was 1.26 besides the model preferred it. And there's a lot of engineering unknowns to CARP scale. So we have issues like dimensional collapse, which is if our embedding is 512, if our embedding is like 1,000 dimensions, we might only be using the first 500 dimensions and the rest are useless. That tends to be an issue with the much larger models though. And there's also loss collapse for large models, which is where for some reason the gradient that you're getting is completely useless and it causes the model to explode and you get like an infinite loss, even if you're clipping the gradient. And this is a thing that's just inherent to very large contrastive learning models, and it's something that's inherent to InfoNCE or InfoLoop as a whole rather than just CARP. So it's definitely a much broader topic for future work, but also for future work. And then there's also inconsistency of clusters, which is like you end up clustering just by noise or by syntactical structuring. You don't really get anything useful. And if you start your clusters like that, it's very hard for the model to learn to get out of that hole. And at the end of the day, while the loss might be really low, it's entirely unusable for preference learning, which we'll get to shortly. So for inference, we use a method called prompt softening. If we have an excerpt from a story, Bill has too big of a hat, and our critique is, I think Bill should have a smaller hat. What we do is we prompt soften by paraphrasing that critique 20 times and then recording the average cosine similarity of each of those embedded critiques against the embedding of the story. This is very similar to how CLIP does zero-shot inference, in which you take an image, you crop and rotate it 128 times or whatever, and you record the average cosine similarity of that embedded and cropped image to your caption. It still relies heavily on having a single good critique for understanding what works best, and the drawback is that it introduces bias from the paraphrasing model. So in the CARP paper, we used Pegasus XL, and Pegasus is trained on CNN Daily Mail, I believe, and it was really bad at paraphrasing because we would get like random things about news in our paraphrases, and it, you know, like if CNN is not talking about a dog jumping over a rock or something, so it doesn't really, it's a little weird. So we have the, we're looking at the visualization of the embedding space of CARP. So each of these call word clusters refers to something semantically significant within the embedding space. And I have examples that I can go into later for what they actually are. But like this giant thing here is this story sucks. And then each of these is like something about like maybe this one I think is character development, and then this one is like something about like dialogue scenes. And there's also additional properties to these clusters that we'll get into in a few slides. But at the end of the day, what it comes down to is that these clusters are graded from like, they'll start from like negative sentiment, and then slowly more and more positive, until at the end they're extremely positive. And this turns to be extremely essential to what we're going to be doing with CARP. I'll get to that in a sec. So if we want to use CARP for things like controllable generation, we need to explore the literature on what's been done with controllable generation before. Models like JEDI tend to rely on single prompts and are greatly restricted due to their dataset biases. So JEDI is trained on like a bunch of subreddits, and like for every subreddit you get a special token. So like Ask Reddit might have its own token, the Science subreddit might have its own token, and the controls have to be with respect to certain subreddits. There's no control with JEDI for coherent story or incoherent story or improved grammar or worse grammar. JEDI doesn't really allow you to express controls like that. Also, prompt engineering is extremely limited in nature. It's very hard to get GPT Neo X20B to generate a story with a plot twist. It's easy to do a plot twist. It's hard to do a plot twist with very specific constraints. So prompt engineering still has a long way to go at the smaller scales before it's comparable to models like CARP. And there's also a bunch of literature in reward guided generation. I'm learning to summarize on human feedback from OpenAI in 2018? Let's just say 2018. And we're going to be going in that direction. So we're going to be using CARP as a critic, as a surrogate for a human reviewer, and we're going to show that CARP actually does provide a very strong signal and allows us to actually control the generation of language models downstream. So a brief introduction to PPO. In a normal language model, you have a query, which is your input prompt. This movie it gets fed to GPT-2, and then GPT responds really great. In the evaluation, you have this movie is really great. You pass it to some classifier, rule, or human, and then that determines your reward. And then if you want to do PPO, you do this movie is really great. You have two language models, your active model and your reference model. You compute the perplexity, the log probabilities for every token for both language models, and you minimize KL divergence between these two models, meaning that you don't want your language model to just start generating complete bullshit, and you also compute the reward on the query and response, meaning the thing that the active language model generated, and then the reward and the KL divergence are added together, and that's used to train the active model. So the KL divergence stops the active model from getting too far away from the reference, so it just doesn't keep repeating words over and over and over and over again. And then the reward is computed given either a human classifier, a rule, or a systematic classifier, and then these are combined to train the model. So in our case, this reward becomes CARP. So from this, we have preference CARP, and we can do reinforcement learning using PPO and CARP. So each token is treated as an action over a story of length n, meaning an action in some state space, and intermediate rewards are computed as log prob distances between the momentum and tuning model, which was this component right here. And the final reward is computed as the score of the generated story, which is the cosine similarity that we have between the critique and the embedded story. In this situation, we're still using prompt softening with Pegasus, so we still get really weird bias. It's not too good. Without prompt softening, though, it's entirely unusable. So the story is scored by CARP as cosine similarity with the desired critique, and as prompt softening. Okay. So here are some examples. We have, I'm in love with a beautiful woman. I hope she likes me too. I write to her often. She wants to be mine. This is why we fall in love. And then the critique for this was, this story is so romantic. And then I think we only gave the first 3 words as a prompt. No, the first 2 words as a prompt. Yeah. And then down here, we also only give the first 2 words as a prompt. And our review is, this story is so scary. I won't read through it. You can read through it on your own. and the model that we used for this was GPT-2 large, 750 million parameters. We were going to use extra large at 1.5 billion parameters, but it was proving to be a bit of a nightmare to get that working because PPO has to store 2 copies of the model, and BF16s didn't want to work. Story for a different time. So there's a bunch of limitations. It's also, using this method is extremely vulnerable to collapse from overfitting on CARP scores. So if we have this story is so happy, happy family was so happy, all they wanted to do was happy all day long. They were happy until they weren't happy anymore. You know, I mean, it's a story. Is it a good story? No. So this requires either meticulously engineering really good reviews, or using insane amounts of data to fine-tune CARP. So CARP is as like most contrastive learning models, CARP is extremely expensive to fine-tune. There are methods to reduce the complexity of fine-tuning, like using prompt tuning or stuff like that. And by this notion, we get CARP Co-op. So we're going to explain co-op models. So we'll just talk about the diagram for a second. When you use CLIP to perform classification, we have here a picture of a jet, and then we have a class. In this case, jet, or a photo of jet, a photo of a jet, and each of these has different accuracies. Or if we just give it a bunch of photos of a jet and we say jet there, and we prepend all these prompt tokens, we can then fine-tune these prompt tokens to find the perfect jet classifier. Similar to CLIP co-op, we can prompt tune CARP co-op. Prompt tune CARP co-op to find vectors that are incredibly good prompts. So the prompt vectors are much better than handcrafted. They're also more robust to distributional shift because the prompt tokens are trained on distributional shift of the images. And we can use KL divergence to get some distributional preferences. So this improves data efficiency rather than using negative log likelihood. We go from like needing like tens of thousands of examples per class to needing only like 1,000 examples per class. At the end of the day, though, we're getting one optimal vector for every class, meaning that we have the optimal prompt for detecting bad dialogue scenes. We have the optimal prompt for detecting plot holes, or the optimal prompt for detecting stylistic choices. So, talking about the data efficiency, we only need about 1,000 examples per class, as opposed to like tens of thousands before. So the example that we're going to use is D&D, a very simplified case of D&D alignments where we have good, neutral, and evil. We initially tried to do all 9 D&D alignments, and we prompted GPT NeoX20B to generate examples of every D&D alignment. It turned out to be really bad at that, really, really bad at that. So this is a much simpler case where it was really good. We had, I think it was like 50,000 stories or something, and then there was a multiple choice question where the protagonist in the story is good, the protagonist in the story is neutral, the protagonist in the story is evil, and we use negative log likelihood for each of those options as part of the distribution for the KL divergence that we were minimizing for CARP co-op. So we have some examples of this. So I won't read through them, but this story is about a good person, this story is about a neutral person, and in both cases, they correctly satisfy the critique. Much more so than prompt engineering NeoX would be able to do. But who wants to like go through and get data for every single kind of critique they might want to use in CARP co-op? Rather, we can use the embedding space that already exists within CARP to find these critiques. So we can start by U-mapping all the clusters to get a notion of pseudo-labels, which is like very high-level abstract labels for each cluster. Not all of the clusters are semantically significant, but this diagram here that looks like a fish, it's a very fun coincidence, is all of these semantically significant clusters. And I believe there's like 26, and I have examples there, but it won't show me my notes, so I can't really go through them. So pretend that I'm reading examples right now. And we can we can compute the centroid of each of these clusters, and we can then compute the distance of some arbitrary embedded story to each of these centroids, and use that as a surrogate for CARP co-op. We also do rejection sampling, so if there's no like dominant axes for these, because these embeddings are 512 dimensions, and it's very hard to get any dominant axes in that case, we reject it. So we want like vectors, story vectors, where one of its components, given this central similarity metric, is like greater than, I think it was 0.3 or 0.4. And using importance sampling like that allows us to actually train CARP co-op on stories that aren't just noise. The real issue with this, though, is that currently we need to hand label and clean the clusters by hand. There's no real way to automate this yet. It's definitely a direction of future work. If anyone wants to work on that, be my guest, please, I'm begging you. So there's also this really interesting property that we saw in CARP models that were successfully able to be used for preference learning. This is a subset of our embedding space on the left, and on the right we have this gradation. That happens. So the red is negative sentiment, and the green is positive sentiment. And on each of these, there's a very strong gradient that goes from negative to positive sentiment. So here you can see everything up from here is negative, and then it goes to positive on that tail. Over here, this is negative, that's positive, negative, positive, negative, positive, negative, positive. And models that we were able to successfully use for preference learning all had this core component. So I think at the end of the day, there's something going on with pre-trained preference models, pre-trained contrastive preference models that we're not entirely aware of at a theoretical level. That like, how can we force this gradation to happen, and how can we use this gradation? How can we use notions of this gradation to create better pre-trained contrastive preference models? Definitely work in that direction. I believe we already have someone working on that, though. I don't know where that is right now. So if we wanted to emulate specific editors using CARP, we could do stuff like prepend things to critiques. Like, I usually really like funny stories, and this actually allows us to establish a prior on editors, and at the end of the day, it also allows us to establish priors on normativity. So, I don't know, I am a child and I think XYZ, or I'm an adult and I think XYZ, and that lets you probe preferences and norms of very specific groups. And this also benefits massively from large language models and scale. If you were to fine-tune GPT-3 as a CARP model, you would therefore gain all the kinds of preferences about children or adults that it's already learned before, and you could use that in this very specific prompt engineering format. The issue is that it's really difficult to find these prompts. Like, you might have a very, very specific group that you want to emulate the norms of, but there's no real way to get norms of that group just by writing a very detailed prompt. You would need very specific data, you need to manually collect data, and if you want to do this for like thousands and thousands of groups, be my guest, but what you could also do is train a large language model specifically to, given a description of an agent, produce these CARP co-op tokens, or produce a prompt for CARP that in turn allows you to explore the preferences of that group, or explore the norms or the biases of that group. So it turns out that this is actually extremely feasible, which is really surprising. We have this hierarchical setup where an upper level model generates the prompt tokens that are then fed to co-op. So we provide the Gyarados, this reader hates horror stories, or this reader likes horror stories, and then Gyarados generates a set of tokens that can be used to control CARP. So CARP now accounts for the reader's unique preferences. However, this only adjusts existing preferences that CARP already understands, and existing preferences that we're already tuning CARP co-op for. If you aren't tuning CARP co-op for some specific set of preferences, being like the pseudo labels, or being like good versus neutral versus evil characters, you can't really use co-op in this way. And a unique reader cannot really introduce new preferences, but it can combine existing preferences in unique ways. This is also, future work is also required for this, but at the end of the day, it would probably require online learning for both Gyarados and CARP. So where is Gyarados now? We're working on a data collection platform called Cheese, which is the co-adaptive harness for effective evaluation, steering, and enhancement. And we have a set of user-specific preferences for stack exchange. we have the required data set for code Gyarados, and we are beginning to conduct large-scale human experiments to validate our findings. And here is an example of cheese, where we have some story that the user presented with. The user can then highlight sections of the story and they write a critique. And eventually cheese will also support things like art, where like art and video, where you might upload a picture where a model generates a picture of some sort or a video of some sort, and the user goes in and highlights and inpaints parts of the video that might be wrong, and then writes some critique about that to help guide the model. So, cheese is very early in development, though. We just started the back end yesterday, I think, actually. But the front end has been, we've been working on the front end for a while, and we've like lots of design documents. So we're not going in entirely blind, but it did just start yesterday. So we also are working on CARP, which is a contrastive learning model built on top of atomic code edits and natural language annotation rationales. And the goal here is to learn granular rationales for very small iterative processes of pair programming. So imagine you have two pair programmers working together and they have chat dialogues while they're speaking. We want to record, while they're coding, we want to record those chat dialogues while they're coding in order to construct critiques from those chats, or in order to use those chats as rationale for controllable code generations. And the idea is if you combine this with Gyarados, what you end up getting is a way to build like very specific red teaming agents. So if you want an agent to red team for like buffer overflows, if you want an agent to red team at the end of the day though, the scope for this is much bigger in a sec. If you want like an agent to red team for like user interactions, or like for different kinds of QA agents, this lets you do stuff like that. At the end of the day, what we're trying to do though with this is eventually get to the ability to red team for like toxicity, or to red team for like debate and other more alignment-y topics. But code proved to be a very, very useful playground for these kinds of topics because there's so much code data available. So where is CodeCarp now? We found that Stack Exchange acts as a great surrogate data set to this pair programming problem. We're augmenting the Stack Exchange data set with data from the Structs Codex, and we are conditioning Stack Exchange answers on user profiles. The hope here is that we're going to be more robust than Anthropic's pre-trained preference model, which used pairwise comparisons over upvotes on Stack Exchange answers, which is kind of silly because it entirely ignores all of the issues that we've outlined here with that. So I'm not going to go into that much detail. And I believe that's it. Yeah, so credits, everyone's Twitter, the lab account, my account, Shablin's account, Alex's account, Ryan's account, Spencer's account. And here's a goose.
Thank you so much.
Okay, so Q&A now. Someone can watch the chat.
Yeah, I got one from chat. Well, maybe does anyone have one in the room? Or should I read the one from chat? I'll read the one from chat. Read the clustering, automatic clustering of high-dimensional data without any prior knowledge of how many clusters are there is a pretty well-established subfield tucked away in its own nooks and crannies. Last I checked, it was coming along nicely. Oh, this isn't even a question. This is a comment.
From who?
I am a little wary of UMAP for generating clusters for a few reasons, but the human cleaning probably undoes some of the side effects.
Yes, that was exactly the reason we were using human cleaning, because UMAP sucks. UMAP is just horrendous.
UMAP is horrendous.
Yes. So right now we need to use human cleaning. Hopefully we can find a better clustering algorithm to use that's more specific to this kind of contrastive learning and something that preserves this notion of gradation. But right now we need UMAP and human cleaning to get this gradation occurring within our clusters. Various other clustering algorithms don't really work for that yet, although I really hope that we can get them working soon.
It looks like Stephen has one.
Yeah, could you say a bit more about the code controlling one? I'm not sure I quite followed the high level story exactly. So like what sorts of control would you want to apply to programming?
So the programming stuff is mostly like for right now the main focus is like infosec type controls, or like controls for like various kinds of pair programmers. So you might want a pair programmer that critiques certain kinds of code more than other kinds of code, or a pair programmer. It's like, you know that your issue is with respect to like some specific class, or you know that your issue is with respect to like you need to improve documentation and you need a pair programmer that helps you go through your code and improve documentation. It's less interested in norms, it's more interested in the code stuff right now is solely capabilities, but eventually it's going to be more safety focused, where we can start using stuff like code CARP or methods created for code CARP in like toxicity red teaming, or like debate red teaming, or stuff like that.
And how like effective did you, I guess, find it to be?
Well, code CARP is, we haven't trained one yet. We're still working on the data set.
Got it.
Yes, this has been in development for about, since like November. It's a really slow process because it's really hard to validate our findings with humans right now. So that's very much in the planning phase, and there's so much work to do. There's so much work to do. Yeah, so we are currently collecting a data set of these atomic edits and rationales, and we are using Stack Exchange as a surrogate for this data set right now, because it turns out that people on Stack Exchange often red team each other. Let me check the chat.
Yeah, there's not another one in chat. I have one. So.
No, people are posting it in.
Oh, in general?
Yeah.
Oh, that's annoying. We told them to post in. Oh no, I don't think there's been questions in general.
Oh, okay.
They're just talking about like technical issues.
Okay.
But I don't see any questions in
Okay.
general. So my question is basically like, what's your like I have like a really high level question, which is like, what's your theory about like kind of like, do you have a way of like echoing like what Anthropic says, where like they try not to advance the state of the art, they try to work within the state of the art without advancing it, or whatever Anthropic said, and like.
Oh, CARP is definitely not state of the art for preference learning. It's definitely state of the art for like natural language critiques, unless you go to like really big stuff like Instruct GPT, because Ethan Perez had a recent paper on using Instruct GPT for natural language critiques, and Jeff Wu has a paper coming out, I think, in about a week or two on that. And I'm pretty sure both of those are SOTA for preference learning, but at the end of the day, contrastive learning still gives you a much more robust approach. It's much harder for the language model to exploit, which lets you do these very, very varied critiques, much more varied than you would be able to do if you were critiquing via prompt engineering Instruct GPT or prompt engineering T5 or something. So you end up getting a much wider gamut of the kind of controls you can actually implement.
Mm-hmm. I guess what I'm really curious about is like what keeps you up at night about these. You said it's like more robust and less exploitable. Like that might help us now with like what we currently see as like narrow alignment of language models.
Mm-hmm.
But like you mentioned this to me before the talk, what like is the plausibility of like unlocking other classes of capabilities by being more robust in that way?
So like you might gain a language model that like never produces plot holes or something like that, or never produces logical fallacies or whatever, right? Is that the kind of stuff you mean?
Sure, yeah. Like, what are the downsides of that?
I mean, I guess I'm not sure at the end of the day. I feel like if you wanted to get something that was inherently significantly beyond the current state of the art for like avoiding plot holes or for writing coherent stories, you need to collect a lot of data, and you need to train a very big CARP. And it's not. I can't imagine it's something that anyone can do. So it's kind of there is a little bit of a barrier to entry there. Although there's no real safety guard in. If you had like millions of dollars, you could do it. You could like use cheese, collect a massive data set of critiques about plot holes, and then train a CARP solely to prevent more plot holes, and then you'd have a language model that like never produces logical fallacies or something. But at the end of the day, is that really what you'd want to use CARP for? Probably not, because it's not like it doesn't use any of the benefits of CARP. You just, at the end of the day, you would be better off just using very bog standard preference learning rather than these natural language critiques, because natural language critiques let you tailor the controls to very specific demographics rather than just use like push brute force capabilities of like, oh, I want no plot holes whatsoever or something.
What do you mean bog standard preference learning? What is bog standard preference?
Like the learning to summarize type work, or the long form summarization work that OpenAI put out about novels and stuff like that. I think it was about 6 months ago.
Yeah.
And the kind of stuff that Jeff Wu's lab does.
Right. We have one from the channel. Why would you want to force the positive, neutral, negative gradients in each cluster? They're happening automatically and mysteriously, right?
No, they're not entirely mysterious. It only seems to happen with declutter, which was really interesting. It doesn't happen with Roberta at all, and Klube kind of messes it up. So it's only with declutter on vanilla CARP, and it's very consistent. It's like shockingly consistent. The reason why you want it is because you can then use co-op to have a classifier of good stories versus a classifier of bad stories, and it's a very robust signal between those two. And if you don't have that gradation, then the model has no idea how to differentiate between good and bad stories with respect to, I don't know, let's say dialogue scenes or something. And then there's no way for the model to actually do preference learning on improving dialogue scenes. So you definitely need this separation of sentiment. Let me check the chat for questions.
Brittany had one.
Yeah, could you talk a bit more about what's going on in the picture with the embedding space? Like what the points are representing?
So each of these points is like a semantically significant cluster. I can actually just check that now. Give me a sec. Where are you? So, sorry, I don't remember what slide this is. There it is. So each of these is like a semantically significant cluster for like, there's issues with the chapter, there's issues with the scene, there's issues with descriptions, issues with character names, issues with the paragraph structure, issues with dialogue, issues with punctuation, and like each of these is separated by sentiment, so positive or negative sentiment. So, wow, the character names are great, or wow, the character names suck, or the character names are inconsistent. Some of these are more useful than others. For instance, there's emotional response to a story event might have different splits based on their emotional response. So with declutter, you might have, this is really sad, or this is not sad enough, this is too funny, or this is not funny enough, and stuff like that. And the fact that you have all this separation is actually what lets you do the preference learning.
Okay. Is this like a cross section of something that's higher dimensional, or like what are like
This?
Yeah.
This is literally running a clustering algorithm and then going through every cluster and figuring out what's actually going on in each cluster.
Okay. So do the points live in two-dimensional space?
Well, oh, that visualization
Yeah.
is just projecting down to R2.
Okay.
Yeah.
Gotcha.
Is dimensionality reduction inherently in the clustering algorithm?
No, I don't believe so. I'm pretty sure it isn't.
Okay.
And what are the, like in the original vectors, like how do you get them? Are they the latent state of something, or?
What do you mean?
Like, semantically, what are those points?
Oh, we just take critiques from the data set and we embed them. That's it.
Okay.
Yeah, so the data set's like 1.2 million stories and critiques, and we just go through all the critiques and embed them, and all the stories and embed them.
Yeah.
Mm-hmm. Any more questions in the chat?
Not in chat.
Okay, any
I
more
have
questions in the
another
room? Yeah, go for it.
Is Stuart Russell right or wrong about
Oh, boy.
like
Oh,
yeah,
God.
no, I'm putting you on the spot for this. Is Stuart Russell right or wrong about the machine like sourcing information about human preferences from human behavior being like a path to robustly safe like systems?
Not on its own. Definitely not on its own. I really think that you need, like, at the end of the day, you need some boosting method. You need a way to filter down to the preferences you want. Because if it just represents every single preference like you're giving it, a lot of these preferences are conflicting. Like an author or an editor that likes sad stories versus an author that likes funny stories will have massively conflicting preferences. And unless you start doing boosting stuff like we're doing with CARP Co-op or some other method of boosting, you're not going to get a robust signal. But it could be that like these very, very large language models are just inherently more robust about this kind of preferences. But at the end of the day, like doing stuff like this gives you more robustness and interpretability, which is really useful when you're doing preference learning. It would be quite terrifying to do preference learning in AGI if you had no notion of interpretability.
Yeah. All right. Yeah, you can.
I guess I'm not sure this question makes sense, but like, if you have like clusters like this, is there a way of like composing things? Like you can imagine you might have multiple preferences.
Oh yeah, for sure. We did that tons of times. So there's actually a really terrifying thing that happened. There was some weird bias as one of the earlier models that we trained where when you told it to generate a funny story, it was like gruesome violence, like horrendous violence. Not even like slapstick. It was awful. But like when you combine that with the preferences for write a happy story or write a good story, like that went away.
No way.
Yeah. So there's also there's a lot of bias in this model, and I wouldn't recommend it. I wouldn't recommend using this out of the box for like value alignment stuff, like at all.
Which model? You mean
CARP.
CARP?
Yeah, I would not recommend using it for any form of value alignment as it stands right now. Maybe in the future.
Yeah.
Once we get like better interpretability tools, and we can verify that this is not an issue.
Cool. Someone's typing right now in chat. I don't know if that's going to turn out to be a question, but do we want to, pending this person, do we want to wrap it up or?
Yeah, sure.
Let's see what Ron AU duck. It looks like a duck.
Oh man, not the duck. Oh, he's cool. He's one of my coworkers. Yeah, I am typing right now. Oh, wait, am I actually? I didn't realize I was.
It's not showing me that you're typing in.
No, I didn't think I was. By the way, you guys should totally follow the lab account, CARP AI, because we only have like 25 followers, and it's very hard to put out newsletters if you only have 25 followers.
I see. Is anyone on Twitter? I'm afraid no one's on. It sounds like no one's really on Twitter.
It's okay.
Well, thank you so much, Lewis, for coming down. And
Yeah.
This was a really interesting talk.